Today we'll learn thermodynamics, and it is the most vital topic of science and comes in both physics and chemistry in class 11. Okay, now if you want to learn this chapter properly, you have to go through from the beginning. That means you have to start from the introduction. And why we will learn this chapter, what are the processes we have to learn, that one we will discuss in this video. Okay, now so what is thermodynamics? Thermodynamics is the combination of two Greek words. This word thermodynamics is the combination of two Greek words. One is thermos, another one is dynamic. Now this thermos means heat and this dynamic means motion or flow. So here the flow of heat or motion of heat we have to discuss. This is nothing but the flow of heat or motion of heat. Okay, so this thermodynamics, this chapter, this branch of science can be defined as that thermodynamics is the branch of science where will accompany with the change of heat energy or some kind of other energies in any physical and chemical process. Okay, that is the thermodynamic. Okay, now we will learn here the chemical thermodynamics. Now it is also a branch of thermodynamics which deals with the change in energy in some processes accompanying with chemical change. Okay, so this is the basic thing of thermodynamics. It is nothing but the change of energy. Now we can say that thermodynamics is not deals with the total energy of a body or total energy of a system. It deals with the energy change. And total thermodynamics is covered by three laws. One is first law, second is second law, and one is third law. And these three laws are not, there is no such proof of this law, and this law we can experience in our human life. Okay, so this is the total thermodynamics, why we will learn this. Okay, now what are the things we have to cover here? And why we will learn this? First of all, this will give you some answers that if two substances or the reactants are put together, if two substances or the things are put together, will they react? First, the question is, if two substances are put together, will they react? Next, if they react, then there will be any kind of energy change. What kind of energy change will be there? And number 3, in the reaction, if the concentration of the substances changes, then will they come in equilibrium? So these are the 3 questions that will be answered in this chapter. Okay, now we know that everything has a limitation. So here is also the thermodynamics has a limitation. What are the limitations? This thermodynamics is only applicable. Chemical thermodynamics is only applicable for the macroscopic system. That is matter in bulk. Thermodynamics is only accompanied with deals with the macroscopic system, that is the matter in bulk. It does not consider any kind of smallest atom, that is microscopic system, that means atoms or molecules. It will not concern about the atoms and molecules. Okay, next, thermodynamics does not tell you about the total energy of the system. It will tell you that how the energy of the system is changes. Next, how the energy of the system is changes. Does not tell about total energy. Okay, so these are the limitations. What are the terms of the thermodynamics? We have to read now only. Okay, so terms of thermodynamics. First, terms of thermodynamics. First of all, we have to learn three things here. One is system. What is system? We have to learn. What is surroundings? Okay, and what is the boundary? Okay, so what is system actually? Anything, system is the parts of the universe. System is the parts of the universe that is under investigation or under experiment. Anything we are taking to experiment, that can be considered as a system. A cup of tea or any reaction mixture, that can be also considered as a system. Now, apart from the system, the rest part of the universe, the rest part of the universe is called the surroundings. Now, how we can say this is a system. This is a system. This is system. Now, this is total universe. This is total universe. This part is called surroundings. This part is called surroundings. So, system is the part of the universe, and apart from the system, the other part which are neighbor to the system, that is called the surroundings. And you can see here the system and the surroundings are separated by a wall. This is the surroundings, this portion is surroundings, this is system, so this is surroundings, you can say. Okay, so this part is called boundary. This part is called boundary. Now, boundary can be anything. It can be adiabatic, it can be rigid, it can be non-rigid, it can be totally isolated. So we can classify the boundary. Boundary can be completely diathermal, boundary can be adiabatic, boundary can be rigid, boundary can be non-rigid. Okay, for adiabatic and for the diathermal, completely diathermal wall we can also use. Okay, and it can be rigid also, it can be non-rigid. Okay, now the terms diathermal and the adiabatic wall. Diathermal wall and the adiabatic wall is applicable for a metallic and non-metallic system. It's applicable for the conductor and the non-conductor system. Okay, we will see later on this. So that is the boundary. Now we will classify the system. Classification of the system. Classification of system. Classification of system. System can be classified in three ways. These are very important terms. We have to learn this before going deep into this chapter. Okay, first of all is open system. Open system. Next is closed system. Next is isolated system. These are the three classifications of the system. Now, what is open system? The system with which there will be no change in the energy and the matter with the surroundings. That is the isolated system. The system with which there will be no change with the matter and the energy with the surroundings. That is the isolated system. That means the system will be completely isolated. There will be no interaction, no change with the in the matter and the energy with the surroundings. Okay, no change of matter and energy. You can use the terms instead of change, you can use the term transfer. There will be no transfer of energy and matter with the surroundings. Okay, with surroundings. Okay, anything a gas kept in a, or the liquid kept in a complete thermoflux, that is a closed system. Okay, it is completely kept in a thermoflux, that is the isolated system. Okay, now closed system. And first of all, let me tell you the open system. Okay, there will be, the system can easily transfer its energy and matter. The system can easily transfer its energy and matter with the surroundings. That is the open system. Very simple, the system can transfer its energy and matter with the surroundings. That is clearly open system. A cup of tea, okay, a cup of hot tea, that is also a open system. Okay, it can transfer its energy and matter with surroundings. Okay, now it is anything, a cup of tea, this is thermoflux. Okay, now what is closed system? Closed, in the case of closed system, the system can transfer its energy with the surroundings but not the matter. The system can transfer its energy with the surroundings but not the matter. Okay, so it can transfer, energy can be transferred but not matter. Okay, so these are the three classification of the system: open system, closed system, and isolated system. Okay, and liquid is kept on in a tube, okay, with the gaseous vapor, that is also a closed system. A cup of hot tea with a cover, that is also a closed system, because the liquid vapor will not come out from the system. Okay, so that is also all of you. Due to some technical issue, the video has stopped, so I have to retake the video. Now here already we have discussed about, I have seen that about a closed system, isolated system, and open system. Now we can classify again the system according to the composition of the system, like homogeneous system and heterogeneous system. Okay, homogeneous system, and number 1 homogeneous, number 2 heterogeneous system. Now what is homogeneous system? It is one phase system. That means the composition is uniform, like pure solid or pure liquid, or only solid only liquid, and it is two phase will be there. In heterogeneous, the composition is not uniform throughout, and it is a two phase system, like gas solid, gas liquid, and it is only liquid, only solid. Okay, so these are the classification. Now already we have classified the system, and already we have done the introduction. So today's video is up to this, and next day we will discuss about the properties of the system and some thermodynamics parameters, like processes, isothermal processes, the adiabatic process, your isobaric process, isochoric process, those processes we have discussed, and also the first law of thermodynamics. Okay, so to see that video, please subscribe my channel, and please hit the bell icon, so that whenever I upload the video, you will get the notification. Thank you.